All right, guys, so now let's solve for equilibrium when they don't give you all the equilibrium or concentrations at the very beginning. So we're going to have to use an ice chart and kind of look through this, okay? So when you're looking at this problem right here, what you're going to first set up is going to be your ice chart, ICE. Now that stands for initial, change, and equilibrium. Now, when you think about these ice charts, okay, what I always do is I usually set it straight under the balanced equations. That allows me to kind of know which one I'm working with so that I don't have to rewrite and not waste my time. When I do this next, what I do is go through and see what the initial stuff that they gave me is. You'll notice that they gave me 12 moles of SO3. So that's 12 moles of SO3. Now, I don't like using moles because I know that I'm going to have to end up in concentration when I do my K. So what I do next is I divide this by the liters that they gave me. This immediately puts me at 4 molar of SO3, and I can use that right away. Next, what I'm going to do is I'm going to fill out anything else that they gave me, and they did tell me something that's at equilibrium already. So what's already at equilibrium is 3 moles of SO2, which I'm also going to automatically change into molar. So once you have that, now you place that right into this problem, 1 molar of SO2. Okay, so now we have everything that we need. What we're going to do next is we're going to start filling out the pieces of the chart so that we can get to the K. I'll write the K down here, which I hope that you all know how to do already. This is going to be the concentration of SO2 squared, concentration of O2 multiplied and then divided by SO3 raised to the second power. Now, in the very beginning, you should know that all the products are going to be 0. Why? Because we don't have any products in the very beginning. Then what we do is we look at the change. Well, we know that this changed by 1. That's how we get 1 at the end. Since that changed by 1, we got to look at the stoichiometry. This is extremely important. When you look at the stoichiometry right here, you'll notice that this is 2 and this is 2, which means those two will change by the same ratio, which means that this will also change by 1. However, since it's a reactant, it's going to be subtract 1. Now we go and we look at the O2. O2 is only half of it because this one is a 1, right? And since it's only half, you're going to only add 0.5, which is half of 1. And once you have that, you're going to write 0.5 down here for the molar, and you're going to write 3 molar right here. Once we're done with that, we just plug in the numbers and we're ready to go. So the SO2 is going to be 1, but it's squared. We're going to have the O2, which is 0.5. We're going to go down to the bottom, which is going to give us 3, but this 3 is going to be squared. So once you have that, you're going to have 0.5 divided by 9. And this is going to give us an answer. So type that into your calculator. Once you type it into your calculator, you're going to get 0.05. I'm going to stop right there and double check my significant figures. It looks like 2. And since it's 2, it's 0.056. Since this is K, it has no units.